So as you know, the Maclaurin polynomial means that it's centered at 0. Now there is a faster way than what we did in class, but since I've only taught you this way, I'm going to carry this problem out by writing the fourth polynomial. When it's centered at 0, we can just eliminate the black part. And now we need to take the derivatives. There's our derivatives for the polynomial, and now for f of x over here. Remember, we're centered at x equals 0, so if I did the fourth derivative at 0, I would just have this expression, and that's equal to the fourth derivative of f when x is 0, which is just 4 to the fourth. So 4 to the fourth divided by 4 is 4 to the third. 4 to the third divided by 2 over 3 is 32 thirds. We've got our coefficient a sub 4. If I come all the way up to the first one, when we don't take any derivatives, it's the 0th derivative. When x is 0, all these terms are 0 except for a naught, and that's equal to e to the 0 power, so a naught is 1, and we continue finding all of our exponents. So we can find all the coefficients, and once we have all the coefficients, we've got our polynomial, our 4th degree Maclaurin polynomial. That's it. Now, if you are curious to see what we're going to be spending some time working on next class, it's going to be how to write this polynomial in a much more efficient way. I'll show you that right now in case you're curious. We could express this Maclaurin polynomial, which is just a Taylor polynomial centered at 0, with summation notation. And I'll start at 0 because the first term doesn't involve using the first derivative, right? So we want the 0th derivative for the first term. Every single term in this polynomial can be expressed a real easy way, just like this. We were always using the nth derivative of our function evaluated at where it was centered, in this case 0. So the nth derivative of our function, where it's evaluated, and for each of those terms, we multiplied by x minus where it's centered, and then in this case, x minus 0. And this is the 0th term, this is the first term, this is the second term, so x minus 0 to the second, x minus 0 to the third. You can see how it works. So we could have just used this formula to come up with this polynomial without developing all these equations of derivatives and doing all that work. It would look like this. Oops, I'm not going to be able to show you in this video because my subscription is still expired and I'm limited to 3 minutes of video. We'll do it in class. Bye.